Assalamualaikum and hi. I'm Faiza from Group 9 want to present our assignment. Okay, let me start. Okay, some introductions. Audio is defined as a term that used to describe any sound or noise that is within a range that human ear is capable of hearing. Any digital information with speech, music that's stored on and played through a computer is known as an or audio file or sound file. One of the common types of audio file formats that have been used today is the MP3. From the audio, we can generate the signal that have a time domain and also have a frequency domain. This assignment that has shown about how to generate the audio become a time domain and a frequency domain or others. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Saifullah bin Muhammad. Okay. In this signal, there are two types of sound, which is infrasonic wave, infrasound, and ultrasonic wave, ultrasound. Okay. In infrasonic wave, have frequency below 20 Hz, which make them inaudible to the human ear. Scientists use infrasound to detect earthquake and volcanic eruptions, to map rock and petroleum formation underground, and to study activity in the human heart. For the ultrasonic wave, sound wave that has frequency higher than 20,000 Hz produce ultrasound. Because ultrasound captures that frequency outside the human hearing range, it is inaudible to the human ear. Ultrasound is most often used by medical specialists who use sonogram to examine the patient's internal organs. Okay. There are two types of wave: longitudinal sound wave and transverse wave. Longitudinal wave is a wave in which the motion of the medium particle is parallel to the direction of the energy transport. Sound waves in air and fluid are longitudinal waves. Transverse waves move with oscillations that are perpendicular to the direction of the wave. Some waves are not transverse waves because their oscillations are parallel to the direction of the energy transport. This is example to the wave and transverse wave. Okay, next. Description and elaboration of theoretical sound. An audio is a representation of sound, typically using either a level of electrical voltage for analog signal for a series of binary number for digital signal. Audio signal has frequency in the audio frequency range of the around 20 to 20,000 Hz, which correspond to the lower and upper limit of human hearing. Audio signal may be sanitized directly or made organic at the transducer, such as microphone, musical instrument pickup, photograph, cartridge, or tape head. Loudspeaker or headphone convert an electrical audio signal back into sound. Okay.
Assalamualaikum dan selamat sejahtera. Nama saya Muhammad Abdul Razif bin Mahmud. Okay, I will explain to you about the coding this. Okay, first, at this line 3, we give a section of a audio file. Audio file at first we record and put it in MP4, but after that I convert to the WAV, so the MATLAB can easy to read that. Okay, after that, this for the time domain. So T is the time, Then there is a formula, the line space 0 line x per fs. Okay, fs is they are standardized for the frequency sampling. It is like a 44100 44,100. Then we subplot it like the 311. Then we plot T as title, as title as a domain, X label as a time, and Y label as a altitude. Okay, after that, in the question, they want a sound for the time domain and frequency domain. Okay, this is our frequency domain. So, first we use an FFT, is a non-Fourier transform. The word is 102. Then we use f equal to line space, ms, and nft. Then the formula is yabs fft and x nft. Itu we subplot that. This is the formula plot. After we got the time domain and frequency domain, we include another audio file for this audio. First audio I record it as my voice, my own voice. Then second voice I include the guitar audio. So we want to use convolution. So z equal to convolution x y. Then we subplot like 313. Then we plot a title convolution, subtitle, x label times and amplitude. So that's the step of the use for the coding in the MATLAB. We want to take out the convolution.
Good afternoon, my name is Tarna Prerachandran. I am from BEEZ 1/2. My metric number is B081910-359. Today I am going to present on result of this project. Okay, in this slide we can see two diagrams, which the left hand side is the Hasik's voice and the right hand side will be the guitar sound and Hasik voice and the convolution of these waves. Okay, let's see the left hand side's diagram first. The first one will be the domain, which is the input wave of Hasik's voice, and the second one is the frequency domain. It will be the output for the impulse wave. Okay, let's see the right hand side diagram. As I told you before, the domain will be the input wave for guitar sound, and the second one will be the frequency domain, output for the impulse wave, and the last one will be the convolution. Convolution is the combination of two waveforms, which are Hasik's voice and the guitar sound. Okay, convolution is the mathematical way of combining two signals to form one signal. It is the most important technique in digital signal system. Thank you.